All right, welcome back. Now we're going to take on the last section in the chapter on factoring. This is called perfect squares and factoring. I want to take you quickly back to the toolbox and take a look at a couple things on here so you can see kind of how this all relates to one another. Okay? All right. On the factoring toolbox, once again, as you move down the page, kind of systematically pick out the tools that are useful, and if you don't need it, move to the next step. So far, we have started out with number 1, taking out the greatest common factor, and then we've tackled factor by grouping, which is a big deal and it affects a lot of other areas. Then we talked about factoring a trinomial of the form ax squared plus bx plus c. Last time we looked at this thing called is it the difference of squares, and also check again to see if anything else needs factoring. Well, that means that only leaves us with one item left, and that's 2b here, so I'm going to circle it. Is it a perfect trinomial square? Now, before we jump into that, I want you to know that a and 2a and 2b here are actually just shortcuts. You don't have to know those. They will speed your work up greatly if you understand how to do it. And if you can't use those shortcuts, you'll just end up factoring the trinomial here, number 3 down here. But they are shortcuts. I'm going to talk about perfect trinomial squares right now. Okay, here we go. All right, last time we talked a little bit about what was a perfect square. I'm going to hit that again real quick so that we know. To square something means to take something and multiply it times itself. Or another way to think of that is squaring it with a little exponent here. So x squared is a perfect square. It's a perfect square because I multiplied it times something times itself. Or if I took a number like 5 times 5, 25 is a perfect square. They are perfect squares because you can take the square root of them and come up with something. So the square root of x squared is x. The square root of x squared is x. And the square root of 25 is 5. So we're going to, by the way, it also could be, the square root of 25 could also be a negative 5. What times itself will give me 25? Well, it could be 5. Or even a negative 5 times a negative 5 could be equal. So with numbers, there could be possibly 2 answers for that. But these are called perfect squares. And we're going to see some trinomials that are called perfect trinomial squares. Let's take a look at one. All right, let's take a look at this one. The instructions are just going to say factor. You know, in many of the problems that we do, when they say factor, what they kind of mean is, can you unfoil it? Can you know what foiling is, of course, first, outer, inner, last. Can you unfoil this? In other words, something was foiled together to give you this. And just to illustrate that, if I took something like x plus 7 and multiplied it times x plus 7 and foiled it, x times x is x squared. Outer terms 7 times x, inner terms 7 times x, and last terms is 49. I get 7x squared. Combining the middle terms, we get 14x plus 49. So you can see that to foil something, if I foil something, I can end up with this. And our goal here is to actually unfoil, figure out how to think about this to work backwards. How to think about it to work backwards. Well, let's talk about it for a minute. You'll notice that this is actually can be written x plus 7 squared. You're multiplying a binomial times itself. We're going to take advantage of that. This whole thing happens to be a perfect square. It's x plus 7 times itself. So this is called a perfect trinomial square. Right now that's a little hard to envision how that's so, but we're going to go ahead and practice looking at the ways in which to factor this. So let's go ahead and do that. Now, we could do this the long way. Well, here's what we could do. We could do it the long way, and I want you to learn the shortcut, but let's talk about the long way. If I was to factor this thing, I'd go, okay, 1 times 49. What are the two factors of 49? What are two numbers that'll give me 49 when I multiply and 14 when I add? I get 14. Well, 49 could be 7 times 7 to give you 49, and it could be 7 plus 7 to give you 14. So if we factored this, we'd say, okay, let's split the middle term, and then factor by grouping. Underlining the two groups here, we get x times x plus 7. When you take it out, leftovers are x plus 7. What had to come out? A positive 7. And then when you multiply it, or excuse me, when you marry these two pieces together, you get this. Okay? Now, what's significant here is the fact that this 7x is actually twice. It's a doubled, something doubled. And we're going to take advantage of the fact that something's being doubled here. And so what we're going to do is try doing this the shortcut way. There are kind of 3 steps to do that. Let's try that, okay? All right, to do this the shortcut way, there are 3 questions you're going to ask. You're going to say, is this a perfect square? Well, it is. And if it is a perfect square, well, the square root of that would be x. And then the third term, you're going to say, is that a perfect square? Well, yes, it is. 7 times 7, or negative 7 times negative 7. And I'm going to put that here. I'm not going to put the sign right now. But now remember, if I wrote it twice, like this, we've got 2 of these now, right? X squared and 49. And what are the middle terms? Well, they are 7x and another 7x. And when I add those together, I get 14. So in fact, the thing is factorable by just saying these 2 factors are identical, or we could write it 7x plus 7 quantity squared. You'll have to rely on the fact that this number is twice the square root of this number. This number is twice the square root of this number. Let's do another one here. All right. Now, I have to determine if this is a perfect trinomial square. To determine if this has got the shortcut, we can use the shortcut on this. Here's the 3 questions again. Is this a perfect square? Yes. Is this a perfect square? Yes. 5 or negative 5. And is this term, outer and inner, add up to this? Well, it does. Or another way to think of that is just to kind of take a shortcut. What if I multiplied these 2 together and doubled it? 5 times x is 5x. Doubled it, I get 10x. That's right. So this is in fact a perfect trinomial square if this were a positive 5. And what that really means is, of course, x plus 5 times x plus 5. 5x in here, and another 5x gives me 10x. Now, this shortcut is a little challenging. If you don't get this one right away, maybe eventually you'll get it, but you don't have to use the shortcut. You can do this with just a long way to do it. Let's try a couple more. All right, number 18, the instructions say, determine whether this is a perfect trinomial square. If it is, factor it. So here's the process. I mean, we could try factoring this the long way, But let's see if we can do it the short way. The square root of this is a, and the square root of this is 12 or negative 12. And if I multiply these two together and double it, 12a and another double that is 24a. Yeah, that's this number. If this were negative, negative 12a and another negative 12a is negative 24a. This is, in fact, a perfect trinomial square. So it's going to ask you to tell if it is a perfect trinomial square. And the best way to do that is to factor it while you're trying to figure that out. Let's try another one here. No, let's say number 20, for example. All right. Now we're going to ask, is this a perfect square? Is this a perfect square? And is this double the square root of that? Okay. Is this a perfect square? No, it's not. I can't take the square root of 2. Even though that's a perfect square, this isn't. So this one is no, it's not a perfect trinomial square. Let's do some more here. All right, we're going to go through the 3 tests. Is this a perfect square? Yes, it is. That would be x. Is this a perfect square? Yes, it would be 9 or negative 9. And is this number in the middle double the square root of that? Well, the square root of that. Well, the square root of that is 9. And if I double it, I would expect 18 here, and I don't have 18. So this is not a perfect trinomial square. Let's try another one here. Number 19, 4y squared minus 44y plus 121. Let's try that. Question number 1, is this a perfect square? Well, yes, it is. The square root of that is 2y. Is this a perfect square? Well, yes, it's 11 or a negative 11. And then is this double the square root of that? Well, let's see, the square root of that's 11. Double it. Wait a minute, if I multiply these two together, I get 22y. Doubled would be 44. Let's see if that's right. 2y and 11, I've got 4y squared, 22y, another 22y. That would give me 44y if these were both negative. Now this whole process of finding the perfect trinomial square is really one of those things you're going to have to just kind of work at a little bit. All right, let's take a look at something related to this, okay? All right, now if you recall, the last step on our factoring toolbox is check again to see if anything needs factoring. And the first step is take out the greatest common factor if you can, right at the beginning. Well, as we look at this, we realize that we can take out a 5 and an a out of both of these. So here's a problem where you're going to have multiple things to do possibly. If we take out 5a, we're going to leave behind a squared, and take 5a out of negative 80a, and we get a negative 16. So 16 times 5 is 80, negative 16 times 5 is a negative 80. So there we've taken out the GCF. But we're looking again to see if there's more to factor. Oh yeah, there is a difference of squares right here. Well, if you remember from yesterday, this is going to be the square root of the first term here and here, the square root of the second term here and here, making one positive and one negative. This is called the difference of squares, the difference of squares. That was from yesterday's assignment. So some of the problems you're going to have tonight are going to involve multiple steps. Okay? Now some problems don't factor at all. We call them prime. Let me show you an example of that. Take a look at this one. Let's see if this is factorable. Okay. You know, it almost looks like a perfect trinomial square, but it can't be because of this negative sign. Negative 4 is not a perfect square. You can't multiply 2 times itself to get that, or negative 2 times itself. So this is not a perfect trinomial square. But maybe we can factor this the long way. Here we go. A times C, 9 times negative 4 is a negative 36. What two numbers will give me negative 36 when I multiply and 12 when I add? Well, let's see here. 1 times a negative 36, their sum is negative 35. That doesn't work. 2 times a negative 18, that gives me a negative 16, getting closer. 3 goes in, 3 times a negative 12, that gives me a sum of negative 9. I just jumped over 12. So this is not factorable, and so we say that it's prime. Okay? These in some ways are the hardest problems to do because you try and try and try to factor it, and you discover it's not factorable. So good luck with those. You just have to try and see if you come up with something that factors. Sometimes they don't factor at all. All right, let's take a look at this one. And once again, we're going to follow the steps of the toolbox. You may use the toolbox on the test if you need to, but I've got it memorized, but if you got it on the side there, that's okay. Step 1, can I take something out of every term? No, I can't. Step 2a, does it look like the difference of squares? No, it doesn't. Does it look like a perfect trinomial square? No, it doesn't. Does it look like maybe this is factoring by grouping? It's got 4 terms. Does it have that ratio? And look here, it's got a 3:2 ratio here. And if I reduce this, I also get a 3:2 ratio. So this may factor by grouping. So let's follow the steps here. Underline the 2 groups. Take something out of the first group. Well, let's see. The only thing that comes out of here is m squared. And that leaves me with 3m plus 2n. Taking out m squared out of both of those. Then we go over here, copy the leftovers. What had to come out of this group? Well, it looks like it was divided by a negative 4. Negative 4 times 3 is a negative 12. That's right, we just took a negative 4 out of that. So now we're ready to marry the pieces. So m squared minus 4 and 3m plus 2n. The 2 shall become 1. All right. Now, this looks familiar. I recognize I go back up to the top and I'm thinking, oh, I got to look again. This is the difference of squares. So the difference of squares is going to factor, or the square root of this, m goes here and here. And the square root of just the 4 is 2. Make one of them positive 2 and one of them negative 2. So the difference of squares factors like this. So there is the factored version of number 11. So what you're going to do is practice a lot of this idea of going down this list, making sure you hit everything, and try to get it completely factored if you can. So the last thing we're going to take a look at here today is solving some equations, and you've done some of these before. So here we go. All right. When you get a problem with an equal sign in it, it's going to say solve it. And if you recall, there are some steps to follow in order to solve this. Step 1 is get it equal to 0. So set the whole thing equal to 0. So in order to do that, we're going to move this 25 by subtracting it from both sides. So if I subtract 25 here and here, I'll get y squared minus 4y, and this is negative 21 equals 0. All right. Now, step 2 is factor it. Okay. So, let's see. 1 times negative 21 is negative 21 What two numbers will give me negative 21 when I multiply and negative 4 when I add? So what times what gives me negative 21, and what plus what will give me negative 4? Well, I can see that this is probably 7 and negative 3. Actually, I got to turn that around. It's going to be 7, negative 7, and a positive 3 gives me a negative 4. So these are backwards. Negative 7 and a positive 3. Negative 7 and a positive 3 when I add gives me negative 4. So those are my two numbers. So we're going to split the middle term. We're factoring by grouping now, okay? Underline the two groups. Let's take out a y. We'll leave behind y minus 7. What had to come out of this group? It was a positive 3. All right, now marry the two groups, y plus 3. Those two hold hands, and y minus 7, the 2 shall become 1. So there we've factored it, and I brought this 0 down the page. All right, but we still haven't solved it yet. In order to solve it, we're going to have to use the zero product property, and that's that property that says if I multiply two things together and get 0, one or both of these must be 0. So let's set each one of these equal to 0. I go into a lot more detail on this in an earlier video, so make sure you watch all the videos here. Subtracting 3 from both sides, y could be a negative 3, and adding 7 to both sides, y could be 7. Now, all of these problems that you have are going to be done by factoring. You're going to set it equal to 0. You're going to factor it, and then you might use the zero product property. The factoring part is usually the harder part, but don't forget that you've got to solve them if they say solve and they've got an equal sign. All right, so that brings us to the last two assignments from the regular part of this chapter. They're both on page 512. I want you to notice, I'd like you to skip problem 15. I didn't put it on here. You don't really have a tool for that yet. So go ahead and do each of these assignments. Make sure you check your answers. This is going to be a labor of love to work through this and get this figured out. So these are challenging. Please watch the videos multiple times if you need to. Factoring is not easy, but at the same time, once you get the hang of it, it's not so bad at all. Okay? So do the best you can. I'm not going to be doing a video again on chapter 9 because the rest of this chapter is all about the review. So you're going to have a test coming up on Wednesday, 26th, May 26th, and that test will be at 6:55 in the evening. So you've got over a week here now to do, almost a week, to do some review. This 61 is about 4 or 5 days, and you can get yourself squared away for this test on May the 26th. Well, good luck with that. Please give me a call or send me an email if you want me to work with you. I will be available on Thursdays at 11 o'clock if you need some help tutoring. All right, take care.